Okay, so I'm starting back up on Inspection Report 2011-008. And they had this one between April 4th and April 21st, 2011. And this is about a year after the leak was discovered and stuff. And this is what I'm talking about as far as, how fractured the information is. You can't find this stuff in one in one report, right? A whole report on this sort of stuff. It's diced and scattered and not easily being able to understand. So now it's a shaft to piston thread, threaded seal, and I could go on. And they're gonna change the name of this seal thread another time, and I'm saying, Jesus, can't you keep the component descriptions with the same thing, or from one inspection report to another? So the design ambient temperature for Type 2 actuator is 150 degrees. According to the vendor design document. The actuator at Vermont Yankees are exposed to ambient temperature up to 185, 190 degrees Fahrenheit, according to the CR. I don't know what the hell. That's an internal report. The result is in a 35 to 40 degree loss of margin for the built-in thread sealant, rated at 210 to 250 degrees. So why is the NR saying that? Why at that point didn't they? Why in this inspection report a year later didn't they say the bunion was the wrong material they should have had 400 degree material in there? These guys. I could talk to you about some of these, especially the inspectors generally are pretty good. They're really good. They know a lot of what they're doing. They're really talented and skillful, and they know how to talk, and they know how to write reports. And as you go up the level, the project managers and up higher, and the executives at the higher level in the regions and at Washington D.C., these guys are special people. They've seen many problems at nuclear plants. They have an extraordinarily wide access to information and stuff. Over and over again and stuff, and so these guys are. I'm telling you, they sit apart of me and you as far as what they've seen and what they've experienced and what they had to investigate and stuff like that. These guys are like Superman, really, as far as the information they got in their heads. They're really different than regular people. I'm telling you, and they're different in a better way than regular people because they've been in the information stream. See, I have one information stream, and that is generally some employees and the NRC and inspection reports, and that's very narrow. Where these guys, they get their internal documents and talking to the inspectors and stuff, and they have an extraordinarily wide view of what's going on. And stuff, and so you have to respect somebody that has a wide perception, wide view of what's going on. They're different people, and there's only a few people like that, really, as you go up the ladder and stuff. And I think that is really, really important. So these. How would I say that? These seasoned people, they should know better than this. And so that, talking about these temperatures and stuff, it's all baloney. It's all absolute baloney. And the NRC should have known that was baloney. That these the 150 degrees temperatures and all that sort of stuff. And then it goes down. The Type 2 actuators had cooling slots, and they put the insulation over the cooling slots. Well, it doesn't matter. It didn't matter because it wasn't a thermal problem. It was the wrong material in there, and it wouldn't have mattered because a lot of that material was very vulnerable to a slight increase in temperature. As a result, the bunion material was exposed to a high temperature for a longer period of time, which increased the potential for degradation of the threaded seals. Well, hey guys, it was the wrong material, right? A year later, and the NRC doesn't know that that's the wrong material. shit, they're not very, these guys aren't very skilled in digging down and finding out what's going on. Or they're playing the game, they knew what was going on, and they're just, you know, giving a bullshit story. Still degraded thread seal condition a year later. Okay, so this is the spiel. Vermont discovered the SRV vendor no longer supported the Type 1 SRV actuator which Vermont Yankee had. The vendor recommended replacing the Type 1 actuators with a Type 2 actuator. The Type 1 actuator was silicone threaded sealant which rated up to 390 degrees, while a Type 2 actuator uses butane polymer which is rated up to 220. They say 210 to 250, but this guy is rated up to 225 degrees. So you know what I'm saying? So you know what I'm saying? Why didn't the NRC say that it was a bad material? Why are they playing this game that it's still degraded? You know, they tell you, you know, they kind of protect their ass type of thing. They tell you it's 225 degree material, but they don't enunciate that, you know, it's the wrong material a year later. It should have been done within weeks of finding the leak and stuff. Why wasn't it clearly enunciated to the public? It was the wrong material. Why are they playing this game of it's thermal degradation and stuff like that? Why don't they have the capability to almost immediately know what was wrong with that seal and stuff like that? And they had indications, like I said, it was a Type 2 actuator. Thus, when the Type 2 actuator was used at Vermont Yankee, the valve was exposed to higher temperatures, which resulted in thermal degradation and air leakage from the actuator. Well, nitrogen leakage. When the Type 10 again, I was exposed to, you know, how can I challenge that inspector? Exposed to higher temperatures. That's so full of shit. It's unbelievable. How is it exposed to higher temperatures? What is the basis for higher temperatures? You know, what is the basis? Well, how come it didn't? How come it didn't fail with the other stuff? Higher temperatures and stuff like that. It's amazing. You know, it's been relatively that same temperature for the last 20 years in the area of that actuator and stuff like that. And there was no, he can't prove to me there was higher temperatures there with this thermal degradation. And this is, you know, as I said, in a nuclear power plant, for anybody, whether it's an engineer or inspector or an employee like me and stuff like that, the only thing that keeps order out of this world is to know what you to see something, to make an effort to see everything as much as you can, and to express the truth of what you see, and then to put it in documents so everybody can see it, you know, and when everybody sees it, a whole group of people put their minds together, you can do amazing things and stuff, and that's what keeps you safe. It's not this you know, laying out bits and pieces and breadcrumbs for years on end and stuff. So, you know, they checked out Vermont Yankee's operability determination reviewed by these and provided a reasonable basis for continued operability until the fall of 2011 due to sufficient margin being available for the backup supply, the pneumatic, you know, the nitrogen tanks. Well, you know, that's not the important thing. They're throwing you off the track on purpose. These guys are, like I tell you, these guys are amazing. They have an enormous knowledge base. And the issue is, how would those valves fail, and the failure mechanism in the worst accident, irrespective of the backup nitrogen and stuff. You know, like I said, you know, you have no ideas really. You have no testing to prove how that thing will fail at all. This is all guesswork. This is all guesswork and estimation. This is not proof. This is not engineering proof. I have proof that backup system, and I have proof that I know how that those components will fail. The threaded seals, I have facts. I know how that will fail with that type of material. I know the true conditions of that actuator and the solenoid valve, and I know if they're either 225 degrees, and I have 400 degrees, and I have the evidence, I have the testing that proves how that thing will fail. That's how you know how safe you are. This is all guessing by professional people, and guessing for a reason and stuff, and it's very disconcerting. Shit.